Hi students. Today Hello everyone, welcome to Sankalp learning class. Today, let us take KCET questions on relations and functions. The first question, let R be the set of points inside rectangle of sides A and B, AB greater than 1 with two sides along the positive directions of x-axis and y-axis. So what is given? A rectangle. Let us take the rectangle as ABCD and let PXY be any point inside the rectangle. Okay, so PXY should be inside the rectangle. Now this distance must be greater than 0 and less than B. Similarly, this horizontal distance, it should be greater than 0 and less than A, because this whole distance is A. Okay, this whole distance is A. Any point in between this AB should be less than A and greater than 0. Similarly, here also, this whole distance is B. So, the point here must be greater than 0, less than B. So, this distance is clearly less than A and this distance is less than B. So, now check before checking. So, let us write 0 less than x less than A. Similarly, this distance 0 less than y less than B. Okay, so check the option. Option A, R is equal to x comma y such that 0 less than or equal to x less than or equal to A, 0 less than or equal to y less than or equal to B. Since x cannot be 0, you can discard this. Same way here also 0 less than or equal to x. You need not have to check further. You can directly discard this. Same way the next one also, see. Here also it is 0 less than or equal to x. So you can discard this. See the last one. R is equal to x comma y such that 0 less than x less than A, 0 less than y less than B. This is the correct option. Okay, so the final answer is option D. R is equal to x comma y such that 0 less than x less than A, 0 less than y less than B. Suppose if the point is on boundary of the rectangle anywhere here, then here it will be less than or equal to. Okay, if it is on this, then 0 less than or equal to 0 less than or equal to y less than it is 0 less than y less than or equal to b. If it is here, then it will be 0 less than or equal to y less than b. Okay, that is how you can choose the answer. Thank you. Hello everyone. Now let us take this question. Let T be the set of all triangles in the Euclidean plane and let a relation R on E be defined as ARB if A is congruent to B for all AB belongs to T. So let us take three triangles. We have here two triangles. One more we will take. Let us take triangle ABC, triangle, triangle ABC, triangle DEF, triangle PQR. Okay. So, what do you mean by congruent triangle? Suppose ABC, triangle ABC and PQR are congruent, then corresponding angles and sides of ABC must be equal to corresponding sides and angles of PQR. Okay. Clearly, triangle ABC is congruent to itself. Therefore, triangle ABC is congruent to triangle ABC. This implies R is reflexive. Okay, R is reflexive. Now, triangle ABC is congruent to triangle DEF. Okay, so corresponding angles of ABC are equal to corresponding angles of DEF. Similarly, corresponding sides of ABC are equal to corresponding sides of DEF. So if you take ulta, that is triangle DEF, triangle DEF, it is congruent to triangle ABC. If you take ulta also, it should satisfy. That implies R is symmetric. R is symmetric. Okay. R is symmetric. So R is reflexive, R is symmetric. Now let us take three triangles. Triangle, triangle, ABC is congruent to triangle DEF. Triangle DEF is congruent to triangle PQR. Okay. So if triangle ABC is congruent to triangle DEF, that means corresponding angles and sides of ABC must be equal to corresponding sides and angles of DEF. Similarly, triangle DEF is congruent to triangle PQR. That implies corresponding angles and sides of DEF must be equal to angles and sides of PQR. That implies corresponding sides and angles of triangle ABC is congruent to triangle PQR. So this implies R is transitive. R is transitive. So R is reflexive. R is reflexive. R is symmetric. And R is transitive. So if a function or if a relation which is reflexive, symmetric and transitive, then we call that relation as equivalence relation. Now let us check the options. First one is reflexive but not transitive, but we have proved R is transitive, so you can discard the first option. Similarly, transitive but not symmetric, but we have proved it is symmetric. Since it is reflexive, symmetric, transitive, it is an equivalence relation. Therefore, it is an equivalence relation. So, option C, equivalence relation is the correct option. Thank you. Hi students, today let us take this question. If a relation R on the set 1, 2, 3 be defined by R is equal to 1, 2, then we need to check whether R is reflexive, transitive, symmetric or none of these. Okay, so the relation R is given by R is equal to 1, 2. Okay, so relation to be reflexive for all A belongs to A, the set. In this case, you can take A as 1, 2 or 3. For all A belongs to A ordered pair, A should be there in R. But here 1, 1, 1, 1, 2, 2, 3, 3. None of these elements are there in R. So 1, you can directly write 1, 1 does not belong to R. 1, 1 does not belong to R. That implies R is not reflexive. R is not reflexive. Okay. Next. 1, 2 belongs to R. It's given. 1, 2 belongs to R. If 2, 1 also belongs to R, then you can say it is symmetric. But 2, 1 does not belong to R. That implies R is not symmetric. R is not symmetric. Okay. So if AB belongs to R, that implies BA belongs to R, then only it is symmetric. Here, that condition is not satisfied. Therefore, it is not symmetric. Next, for transitive, AB belongs to R and BC belongs to R. Then, if AC also belongs to R, then it is called transitive. But in this case, we don't have this type of such pairs. We don't have such pair. That case, we can assume R is transitive. Okay. If you don't find any such pair, you can assume R is transitive. So R is not reflexive, R is not symmetric, but R is transitive. So first option, R is reflexive. You can discard that one because we proved R is not reflexive. Second, it is transitive. We have proved it is transitive. This is also not true. So the answer is option B, R is transitive. Thank you. Hi students, let us take fourth question. Let A is equal to 1, 2, 3. Consider the relation R is equal to 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 1, 3. Then we need to check the four options. First one, A, R is reflexive but not symmetric. B, R is reflexive but not transitive. C, R is symmetric and transitive. Last one, neither symmetric nor transitive. Okay. Now, check 1, 1, 2, 2, 3, 3. All three elements belongs to R. So for all A belongs to A belongs to R. So for all elements 1, 2, 3, 1, 1, 2, 2, 3, 3 belongs to R. Therefore, R is symmetric. R is symmetric. I'm sorry, R is reflex. R is reflex. That is reflexive derivative. Okay. For all A belongs to A belongs to R. Therefore, R is reflexive. Now, consider 1, 2. 1, 2 belongs to R. 1, 2 is there in R. But 2, 1 does not belong to R. This implies R is not symmetric. Why? Because AB belongs to R, but BA does not belong to R. Therefore, R is not symmetric. Okay. Next, consider 1, 2 and 2, 3. 1, 2, 2, 3. See, these two elements must be same. 1, 2, 2, 3. If 1, 2, 2, 3 belongs to R, check whether 1, 3. Leave these two common elements and take the last two. 1, 3. If it is there in R, then it is transitive. But you have to check all such ordered pairs. Okay. So, implies 1, 3 also in R. 1, 3 is also in R. Now take another such, you select such pairs. Which one you can take? 2, 3 and 3, 3. 2, 3 and 3, 3. See, these two are same. So, 2, 3 also belongs to R. So, for this pair also it is true. Any other possibilities? 1, 1, 1, 3. 1, 1, 1, 3. So, if you leave these two, you will get 1, 3. It is also in R. Correct? Therefore, it is transitive. Therefore, R is transitive. Okay. So, R is reflexive, R is not symmetric, and R is transitive. Now take the options. Option A, reflexive but not symmetric. It's true. Correct. Reflexive but not symmetric. Option B, reflexive but not transitive. But it's transitive. So you can discard this. Symmetric, transitive, but it is not symmetric. And it is transitive, you can discard. all other. Therefore, option A, reflexive but not symmetric, is the correct option. Okay. Now, hi students, let us take fifth question. Let R be an equivalence relation defined on a set containing 6 elements. The minimum number of ordered pairs that R should contain is. Okay. So in R, there are 6 elements. In R, there are 6 elements. Okay. Suppose, let us take A as 1, 2, 3, 4, 5, 6. Okay. In A, there are 6 elements and you need to check R such that R should be an equivalence relation. You have to set R like that. But you have to take minimum number of elements. Okay. You need to take minimum number of elements. So first R should be reflexive. So to be reflexive for each A should be in R. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So for each A, each 1, 2, 3, 4, 5, 6, we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. They are there in R. So R is reflexive. For transitive, if you take any element, if you reverse it, you will get the same. So for symmetric, if you take any element, reverse it, it will be same. So it is symmetric. So since we don't have any A, B, B, C such pair, you can assume this as transitive. So this is the minimum number of elements required to be an equivalence relation. So if there are 6 elements in A, if there are 6 elements in A, R should contain 6 elements to be an equivalence relation. How will be those 6 elements? It is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Like for all A, AA should be in R. So if you show all the elements required for reflexive, then that many elements are enough to be an equivalence relation. Therefore, option C, 6, is the correct answer. Got it right? So check number of elements in the set. The same will be the minimum number of elements required for an equivalence relation. Thank you. Hi students, let us take the question. Define a relation R on A is equal to 1, 2, 3, 4 as XRY if X divides Y. Then you need to check R is first option reflexive and transitive, B reflexive symmetric, C symmetric and transitive, and last one is equivalence relation. So